Here's a photograph of my two older sons and I. We built this vehicle during the spring and summer of 2014, just before Peter went on his mission to Farmington, New Mexico. The main purpose of the project was to provide a practical learning experience for my children, and it certainly did that. They learned how to use CAD systems, how to weld, and all about hydraulics. Here are some goals that we had as we designed and built this vehicle. First, we wanted it to have a 100% hydraulic drivetrain. I teach ME 465, which is our fluid power class. It's a technical elective in mechanical engineering, where we study hydraulics and pneumatics. So one of my hidden agendas was that this be all hydraulic to allow me to study more deeply implications of hydraulics in vehicle drive systems. We also wanted to use a low power engine for safety concerns and also to force ourselves to think carefully about efficiency. We figured somewhere between 10 and 20 horsepower would be sufficient. We ended up using a 13 horsepower DeWalt engine that's used on a DeWalt pressure washer, and we found that 13 horsepower just wasn't quite enough. So once we save our money, we'll probably replace that engine with something a little bit bigger, maybe 17 to 20 horsepower. The top speed needed to be between 20 and 25 miles per hour. It needed to have sufficient torque for steep inclines and rugged terrain. It needed to be amphibious, go on land and in water, and of course here in Rexburg it needed to plow snow in the winter, and it needed to fit in my backyard shed. We got the vehicle running just 2 weeks before my son went into the MTC. We brought it out to my neighbor's property and tried out the steering, and we found that the skid steer really does have a very small turning radius. It works beautifully. The vehicle seems to get about a top speed of 20 miles per hour, and we even tried it in the water. As we go off this edge here, it gets to be about 8 feet deep, and we found that it does float. So it can go in the water. You certainly won't break any speed records in the water. You can't tow a water skier behind you, but it floats. We were happy about that. We still need to save up our money for a paint job, and here are some ideas we're considering. This is a camouflage look that's my personal favorite. And here's a more wild idea with flames on the front. I'm going to bring up a CAD model so that we can talk about how this works. You heard me before talk about a skid steer, very similar to a cat tractor or a bobcat. If I move this joystick forward or backward, it causes the wheels to drive either forward or backward. The same with this other joystick. So if I want to turn really sharp, I can move one joystick forward while I move the other one backward, and it will turn on a dime. The joysticks are dual axis. I can also move them in and out this way. This joystick will cause the plow blade to lift and lower, and this joystick will cause the plow blade to tilt one way or the other. This is the hydraulic drivetrain. Notice there are no drive shafts. The engine simply turns 3 different hydraulic pumps. Here's a CAD model of the ATV. First of all, I will hide the seat and the hydraulic reservoir so we can zoom in and take a look at how the engine is simply driving 3 different hydraulic pumps. One pump runs the wheels on the right side of the vehicle, the other pump runs the wheels on the left side of the vehicle, and the third pump, the smaller pump on the end, runs the auxiliary hydraulic components, such as the plow blade. So you may be wondering, how does the hydraulic pump actually get the wheels to turn? Well, let's rotate this around and take a look at what this hub looks like. I'll zoom in here. This is a hydraulic motor. When hydraulic oil is piped to this motor, it will force the wheel to rotate. Each wheel has its own hydraulic motor. Therefore, it is truly 6-wheel drive. Each wheel has its own motor and provides drive. You'll also notice that it is independent suspension. Each wheel has its own shock. Let's zoom in again to this hydraulic drivetrain. You'll notice the 2 larger pumps have a hydraulic piston that will adjust the flow rates of these pumps. As the operator pushes the joystick forward, the hydraulic piston will change the swash plate on the pump, causing the vehicle to go faster and faster. If the operator pulls backwards on the joystick, the hydraulic piston will pull the swash plate the other way and cause fluid to go in the opposite direction, causing the vehicle to go in reverse. Here's a CAD model of the suspension. I'm going to cut a cross section so that we can see what's going on inside. You'll notice that there is a wheel hub and a tire and a valve stem. You'll also notice that there are some lug nuts that are attaching the wheel to a bolt plate that's welded to a shaft. The shaft goes through a double row angular contact ball bearing. A hydraulic motor has a keyed shaft and inserts inside of the wheel shaft. So as the hydraulic motor turns, the wheel will turn. I have posted a complete drawing package in PDF format on the internet. Here's a link and feel free to download it. It contains 33 drawing sheets showing the entire design of the ATV. It includes drawing sheets showing how to assemble all of the components, as well as drawing sheets showing how we created the frame and the roll cage. And it also includes all of the drawings for the suspension and the drive system. In all, it turned out to be an incredible learning experience for my children and I. After my sons and I had completely built the ATV, I realized what a great learning experience it was. So I decided to incorporate it into one of my classes at BYU, Idaho. I teach ME 280, Practical Mechanical Design, a perfect fit for a project like this. For their semester project, students focus on the design of the ATV suspension. They create a complete CAD model of the ATV suspension and drive system. They create drafting drawings, and each team in the class builds a complete suspension assembly. They learn how to use computer numeric controlled milling machines and lathes, CNC plasma cutting machines, fabrication equipment, and how to weld. This has truly turned out to be an exciting learning experience for everyone involved.